folder in the final results. And I'll explain what your exam or question will be. So, gem. This is basically the work where we're trying to optimize energy consumption for Android GUIs in Android applications. And the problem is not new. In fact, there are several different papers that try to tackle this problem from different points of view. And fairly well-known groups tackle this problem. And basically, state of the art can be summarized across different dimensions, but when it comes to optimizations, everybody is just taking one single objective into account. They would like to minimize energy. Okay? When it comes to color schemes, all these solutions are usually relying on predefined, original, polite transformations, and they're considering only individual movies. Okay? But obviously, in reality, we have multiple screens. We have different time we spend on different screens, and these tools don't take this into account. And obviously, the main question, if you want this tool to be practical, you have to take all these things into account. If you don't take all these things into account, then you're taking assumptions. Yes, it may be easier for you to do the paper, but you're not really solving the problem. So the goal here for us was to solve the problem. And what we wanted to do with this tool excuse me. The symptoms of the bug are always the same. And I have lots of double debug papers. So, the idea with this tool and many other tools, we wanted to make an impact. We didn't just want to write yet another paper. So in order to accomplish this goal in mind, we had to take all these things into account. So if you want to really solve the problem, then you need to really solve these. First of all, we would like to provide solutions that are visually attractive. However, we're not going to be relying on predefined deleting is in previous approaches, so we're going to have large space of potential solutions. Also, we don't want to be doing this just for individual screens. We want to do this for multiple screens. And obviously, there is another problem here, because we would like to maintain consistency across different screens, right? We don't want to generate a solution with a certain set of colors for one screen and then suddenly change it for another screen, because that is not going to be usable. And if you use one of the state-of-the-art approaches, that's exactly what they do. They don't take into account consistency. We also want users actually to use our application, right? And many users don't want the applications to be instrumented. They don't want to give away private data. So we want to do this in non-intrusive fashion. And importantly, we would like to take into account usage time. How much time users spend on different screens, right? Because that will determine how much energy is consumed by different colors on the screen, depending on how much you spend on that screen. And if possible, we would like to improve original design. So these are all additional things that we wanted to take into account while solving this problem. And solution indeed turned out to be non-trivial engineering solution because first of all, we need to rely on power modeling. We would like to be able to do estimation in online fashion. In other words, in our early MSR work, the way how we estimated energy consumption, I didn't include the screenshot here, but we needed to connect our phone to actually power measurement monitor, which is if you want to get really low-level energy measurements. But obviously, you will not be able to do that in a practical setting. You cannot ask a developer to connect your phone to all those wires because We will never do that. We don't have time for that. And it's not that easy. We actually needed to talk to electrical engineers to be able to do that exactly. So the idea here, we would like to be able to build reliable enough power models to do the estimation for the given screen. And luckily, we can build this power model beforehand, and then we can use this power model just to estimate energy consumption of the generated solutions. We also rely on dynamic analysis, which does not require instrumentation of the APK. So this is one of the components that we are using from our infrastructure, right? So the idea here, why do we need dynamic analysis? Because we would like to explore the application. We would like to exactly get information where the components are, what their colors are, what the borders are. Because we would like to get precise information about all the, not only the pixels on the screen, but also the components on the screen. Because when it comes to creating consistent design, it's not just about pixels, it's about components and contrast among those components. And that's what we need to know. Also, we tap into pixel-based accurate detection of colors in borders, text, backgrounds, and blue components. We rely on color theory for large universe of visually appealing color schemes. And finally, we are using multi-objective optimization here to tackle multiple objectives at the same time. So in other words, we would like to minimize the energy, but we would like to take into account multiple screens into account. We would like to take usage time in each of those screens into account. And we would like to do that for subpixel level power model. Okay? At the same time, we would like to maximize the contrast between different components, because hopefully that will result in visually appealing solutions. And at the same time, we would like to minimize the distance to the original design. So we don't want to suggest solutions which are completely outside the box. We want to suggest solutions that users are familiar with, but that consume less energy, and that hopefully improve the contrast. So this is why we need multi-objective optimizations. Okay? So again, the idea here is that we run systematic exploration, as you can imagine, if we have real data from the field, again, we can generate test cases by relying on real data. In fact, I'll tell you more, but this tool is also currently being adopted by a major telecommunication company, and they actually asked us to build more tools to make this actually usable in their context. So one of the things that we build an application that runs on the phone that allows collection of that particular scenario that you are running your app with, that exactly helps you to estimate the amount of time you spend on different screens, which is exactly equal to our optimization algorithm. So I'm not going to go into the details of how we encode the solutions, but this is fairly straightforward, but the details are in the paper, but there is quite a bit of engineering which happens before you encode the solutions which are input to the genetic algorithm here. And the output of the algorithm is a Bertha front of solutions, which look like the following. So this is a real demo of Gemma prototype that we developed. Basically, what you see on the screen, this is your original application. These are the color schemes for your original application. These are different gadgets here which tell you how much energy this particular solution consumes. This basically shows you the contrast. And this shows you the distance to the original design. This is 0, because this is the original design, right? But you can actually explore alternative solutions which are suggested by Gemma here. So for example, if you pick one of these solutions here, then it immediately applies the solution to the application and it shows you energy measurements for that particular solution that you are exploring your product for. So this is basically the idea behind Gemma. Okay? I hear some positive feedback. That's exactly what Huawei thought. They said, we love it, and we want to put it in our developer ecosystem. So in other words, we want to offer this to developers so that they can estimate energy consumption for their GUIs. And we said, great. But they said, you know what, we can actually redo it from scratch. because we actually have many more other requirements and user scenarios that we would like to take into account. And this is actually a current snapshot of the current prototype that they have. So I'm not going to go into the details, but the bottom line is this is currently being implemented, and the next step for them is to convince the management to actually adopt it with their ecosystem that they're trying to put together for our developers. Now, it's like with jazz, right? I mean, it's light music, but it's very complex to play, right? Same thing with this research. On the surface, it looks cool, but there is a lot of work that happens under it. Actually, tremendous amount of work. And we call this work execution engine. So basically, if you want to run all these things, and you want to run all these things in parallel, and you want to run thousands of these instances, you need an infrastructure. This is what we call execution engine. We build it by using open close principle. The idea here is that we would like to our clients to communicate to the server. On the server, we're going to have workers. These workers are tools which implementing things like JAMA, Crash-Scope, Fusion, and we would like to be running multiple instances of that. We would like to be running multiple instances of Crash-Scope if we want to do, if we want to analyze many applications in parallel. So this particular implementation actually enables a synchronous communication between clients and workers. The idea here is that clients basically put their requests on the message bus. Message bus in this case is implemented using an NoSQL CouchDB. So basically they put the request in JSON format in this bus, and then one of the workers who understands this format picks up the task, and then this worker then talks to the dispatcher, and dispatcher knows what kind of resources we have, and in our case we have phones plugged into the server, we have emulators running on the server, and the dispatcher knows which resources are available at this moment in time to assign for this particular task. And then once this request is completed, let's say we ran first code for that particular APK, we put the results back, and the client picks up the results and visualizes the results. So in this particular case, for example, we have JAMA, right? So JAMA put the request here, the worker executed APK dynamically, then the worker also ran GA to produce all these solutions in the Pareto front, put all these results here, and we have this nice visualization on the client side to show all these results. Of course, we designed this infrastructure in mind that we'll have many more clients in the future, and we'll need to implement many more workers in the future. And of course, we'll be adding many more things to our pool of devices, or farm of devices, our emulators. So what is the big vision here? The big vision here is that we are hoping to build a developer ecosystem, right? So this ecosystem is built on top of all these tools that we've designed and built, and there is quite a bit of work which is going in terms of analyzing this data using language models and using more advanced techniques. And the idea here is to support all these tasks, right? Some of these I discussed today, some of these work in progress, and all these tasks run on this execution engine. So this is a big idea of where this all is going. Some of the really cool ongoing work, and this work essentially what originally motivated all this work, is ideally we would like to be able to automatically take information from those user reviews, and we would like to be able to use that information from user reviews to test these applications. So assuming that we can identify user reviews that are useful, we would like to steer test case generation. In this case, for example, you have real data from the field, you build a language model based on that data, but we would like to be able to steer that model to generate test cases that would help us to cover issues that users identify in the client. So this is goal number one. Goal number two, if we are monitoring libraries that this application depends on, we know which APIs are changing frequently, we would like to be able to steer language model to cover parts in the application which are using those APIs. So this is really where we would like to get from this point. Now, so let's keep this animation. Cool part. While designing and building all this, obviously we run into the whole slew of issues, right? And some of these issues we call essential issues. But for most of these issues, for essential and accidental issues, we had to come up with solutions on our own. And this is actually a really challenging part of engineering research, in this case like that. Because you're hoping that you're going to work with this tool and you're going to run into some question, but that's okay, because you have Stack Overflow and somebody already solved that problem. All you just need to know is to find a solution, right? But a much more complicated case is that you're trying to do something really novel that nobody knows how to solve. You have only questions, but there are no answers, right? And these are exactly instances of problems that we ran into and some of the solutions that we had to come up with. So some examples of essential challenges here are test oracles, for example. How does one design an extensible GUI-based oracle that can be used to verify expected application behavior across different device configurations? Well, I'll show you a partial solution for this. We also have an issue that is due to event coordination. So some of these record and replay tools are really cool. They claim they do time warping, but they don't tell you what kind of problems you get when you do time warping, because there are various issues related to proper timing of events. In some cases, you cannot fire events as fast as you can fire them to get meaningful execution. So this is a challenge, and I'll show you a partial solution that we have right now for this. Problems that we don't have reliable solutions for right now are how do you deal with external features? How can external features such as notification be properly incorporated into large-scale testing of mobile apps? Or how can you deal with external dependencies where mobile apps use some servers or services or databases in order to receive and communicate information? And how these dependencies can be properly incorporated into large-scale testing. Also, we have a number of accidental challenges, and I'll show you some of the, in this case, complete solutions and partial solutions. So one accidental challenge is due to application data in cold starts. So one of the obvious mistakes that you can make in this area is that if you try to reproduce the results of the test case without cleaning the state of the application. So you're basically trying to run it again, but you already have some data, which is essentially will lead you to some new states. So this actual problem can be easily solved. I'll show you how. More interestingly, we found some real bugs in Android framework that we had to fix ourselves in order to enable, for example, I'll show you the problem with counters. Also, we found bugs and limitations in SDK tools, such as, for example, inherent limitation of ATB server that you cannot run more than 15 instances of Android virtual devices at the same time. And obviously, for that, the obvious solution is to run multiple servers. And I'll show you some of the challenges scaling up concurrent virtual devices. So the first one for a test oracle problem, basically, the partial solution that we came up with relies on using oracles from UI hierarchy. So the idea here is we don't have to take the screenshot, but we can take exactly a slice of information that we need to design the oracle by relying on UI hierarchy. Of course, we may miss some fine-grained information, for example, colors, images, but in many of the cases that we had to deal with, this was enough to build reliable oracles. When it comes to event coordination, you actually need to get precise information about the state you're currently in. So in other words, you need to make sure you are in idle before firing the next event. In many of these time warping approaches, they don't actually check the state of the application before they fire the next event. In that case, you're not going to get meaningful sequence, so that's one of the solutions. For external features, we don't have good ideas. That's one of the questions for you. Right now, the only suggestion that we're trying to do is to try to basically rely on real data to try to model some of these external notifications. And for application data and cold starts, obviously the solution is to clean the data, which can be done fairly easily. Couple of issues that we had to fix in the framework utility, for example, one is due to the application counter, because we actually couldn't get a reliable UI hierarchy, so we had to modify the underlying utilities of the framework to be able to do that. We also submitted bug reports to Android. We're still waiting on some of the responses. When it comes to some of the limitations, as I said, ADB server allows only 15 connections for unknown reasons. So basically, if you are to scale this up, you have to run multiple servers at the same time. So this is an example where we, for example, run 2 servers and in one case 15 virtual machines, but in one case 12 virtual machines per server. So this is my Android team. It will be Mary. These are some of the papers that we published related to this work. Now, I have virtual machine for you. It's going to come on this USB stick. Basically, you don't have to use virtual machine to complete the assignment that I will have for you. But if you basically want to use virtual machine, that you're not going to run into any path problems. But if you want to use original SDK tools, you can also do that. You can just install it on the machine, but you'll need to configure your path settings. This is an Android emulator for 4.4.2. This is Ubuntu Linux. You need to have VirtualBox installed, and you'll be able to run this virtual machine. What we've done, we've prepared a pretty cool file called useful commands, txt, that you will find in the virtual machine. Essentially, it will tell you how to use many of these utilities, such as ADB server, get event commands, UI hierarchy, hierarchy viewer. So all these are essential building blocks if you're going to be using or building tools relying on these technologies. We have all the examples in this file. You'll find them on the virtual machine. So now let me show you just what we can do here. So basically, the first one, we're going to install MyOGPK. So this is a terminal running within the virtual machine. This is our Android virtual device. So we're going to first install this APK. This is MyOGPK. And then we're going to start this application on our device. And so basically, we're controlling this APK from the terminal. That's what you will be doing as part of the assignment as well. After that, we're going to start tapping. So we're going to start sending ADB shell commands to tap on certain parts of the screen. And then you will see later, we will get some UI snapshots and hierarchy using UI estimator and hierarchy viewer. And we're going to visualize that. So anyway, that's what you get. This is an assignment that I came up with for you. Basically, it's not super difficult. I encourage you to actually try to do it natively. Just try to install Android SDK natively. If you don't want to do an easy solution, use virtual machine. So I provided several APKs in the folder in virtual machine. So you need to start the emulator, enable point your location, install and start the app with the emulator, and then you are required to record the use case that tests one feature of the application. Okay? And then you need to create a shell script using ADB input commands to exercise that script to test that feature. And then you need to take a screenshot UI done for the first and last screen of the use case. You need to send those 2 files to me, and I'll do it. Okay? These are some of the open questions for discussion. We have a little bit of time left. And at this point, I'll take any questions you have. And by the way, I think I'm ready to give you back. No. Sorry. So 3.5 gigabytes. It takes some time, but you can just use the link to download.
Taking questions.
Yes, any questions? It's the end of the summer school, so thanks.
No question for audience. You want to challenge the audience with your questions?
These are take-home questions.
Yeah, these are take home.
If you can answer any of them on the spot.
There's also a prize if you make a question.
Yes, always can be
Just now, not before. The prize is now.
Okay, it's a technical question. What kind of tool you use for this static analysis?
We use SourceML.
Okay.
Just type SourceML in Google, you'll get directly to the website.
And for the dynamic analysis, you use any kind of tool or just run it in the emulator and then use some? Because I mean, inside the log we have many information. The question is, some of this information are available only from an operating system at the operating system level.
Yes.
So you show that with the UI automator you can infer actual interaction just looking at the log. So what kind of log have you used to actually infer these actions?
So we are relying on get event command to extract low-level log. And then, as I said, we're doing translation by rerunning. First of all, we're doing translation from those logs to ATB commands. And then we are rerunning those commands in a step-by-step mode on the phone. And then at each moment in time, we take a snapshot of UI hierarchy. And with difference UI hierarchy, to identify the differences in states to build a model.
Thank you.
I have a point for discussion on that. So, do you think that automatic bug fixing techniques might be more successful on this type of application, given the fact that they are all built on top of the same set of APIs, that they are all built on top of the same operating system, basically, with respect to standard software to other types of software? Because exactly here, the similar pieces of software across different apps are even much more than what Fran was presenting yesterday.
Yeah, what comes immediately to mind is the fact that if you have API-related problems, right, those problems can be fixed if you have a solution for one instance in one application. Potentially that could be used to, or reused, that solution could be reused in some other application that uses the API. So this is what comes to my mind immediately. Of course, the challenge here is so in this case, let's say you have two applications and you have field data for both applications. So you can build models for both applications, right? And let's say you have a bug in one API, but both of those applications using the same API. Let's say speech to text API, right? And you have a solution, you identified the problem, you discovered the bug, and you have the solution in one of the applications, right? So the question, how can we reuse the solution in some other application where this particular API is used, right? I actually think it may be closer to the Muse work that Rocco presented.
I don't know, I was not here.
Yeah, API usage problem, how do I use this method?
Okay, yes, maybe yes.
So the idea here is if you have, let's say, misused API instance, in one case you, and there is quite a bit of work going on detecting misused APIs, I think, from WebYard. So similar solution can be applied in a different context. Right?
Yeah.
Interesting case here is how you validate that you have a similar test case for a different application. That's something which I don't have an immediate answer for, because the data usage data may be different and usage scenario may be different. Somehow you need to reason about equivalence of those test cases, right? So yeah, that's an interesting.
Other questions, comments?
Thank you.
Thank you.